Welcome to EbbiCoin. If you already know about us and what we have to offer, feel free to click the Participate in Sale button in the menu or underneath the About Us section and create an account and join the sale and get your EbbiCoin now before they're all sold out. If you already have an account, just click on the Already Have an Account and log in here with your username and password that you used when you signed up for EbbiCoin. For everyone else, my name is Jordan Keys and I am the inventor and CEO of EbbiCoin and Quantum Data Solutions. I had the idea to create EbbiCoin 10 years ago, but the technology that I wanted to integrate and the security that I wanted to implement just did not exist at the time. And at that point in time, I was told by multiple programmers and developers that what I wanted to create didn't exist and it just could not be done. And in the last 10 years, I decided to hone my skills in programming and development so that I could actually start to create the ideas that I have. I have a ton of innovative and new ideas and products and services that I wanted to bring to the world. And up until now, I could not create them because I could not find the coders or developers that actually had the skill and availability to do the things that I wanted. Now that I've become a skilled programmer and developer, my focus has been on actually creating these amazing new technologies like EbbiCoin and like the EbbiCoin blockchain. I've poured the last 6 months, 10 hours a day, nonstop to develop a new technology that actually enables the ability for me to build the blockchain with all of the functions and features that I dreamed of. A blockchain that's faster, more robust, dynamic scaling for block sizes, instant finality, data persistence, offline transactions, peer-to-peer transactions, mesh network, and quantum secure, meaning that quantum computers from now for the next 100 years cannot hack our blockchain, our wallets, the way that we do our entire ecosystem. The same thing with supercomputer clusters from anything from nation states or governments, any sort of bad actor that wants to hack. We have 100% quantum and supercomputer protection built directly into the blockchain. And EbbiCoin is just the front end where users can participate in the new technology that I've created. And on the back end, this technology is perfect for large companies, corporations, governments, and the banking sector so that we can create side chains for all of those companies for large licensing fees, and we'll force them to use a portion of the EbbiCoin on the front end. So if you're a holder of EbbiCoin, every time we lock up a new deal with another corporation or government or bank, everybody holding EbbiCoin will actually benefit as the supply of EbbiCoin goes down, as all those companies have to spend the EbbiCoin to do the transactions on their side chains, and that means the value of all the EbbiCoin for you guys goes up. There's also only 78 million EbbiCoin that are going to be mined on the Genesis block, and 48 million of those are going to be sold during this pre-sale. That means there is not a large supply of EbbiCoin. Unlike other blockchains, of which EbbiCoin is far superior, that have hundreds of millions, billions, and tokens sometimes even have trillions of supply, which makes it almost impossible to see a significant rise in the value if you're a holder of those coins or tokens. And as I mentioned before, EbbiCoin is leaps and bounds ahead of anything that's out there. Every other blockchain, every other project is basically a clone or a fork, where they take what's been out for a long time, 10 to 20 year technology, they basically copy everything completely, and then they change a few minor things. They change the name, maybe the colors, and maybe the block time goes from 5 minutes to 4 minutes. Maybe the block size goes from 1,000 transaction to 2,000, but it's a basic clone that every single blockchain uses, which makes them all basically exactly the same, using the same antiquated technologies, and also having the same problems with transaction times, the same problems with finality speed, the same problems with being able to be hacked by quantum computers and supercomputer clusters, tons of vulnerabilities and an extreme amount of issues that makes it impossible for them to become mainstream, and it makes it impossible for them to replace things like the SWIFT system, banking, replace Visa and MasterCard systems. It's just impossible with those other inferior blockchain technologies. It's impossible. With EbbiCoin, I've done the complete opposite of all of that. I have coded this blockchain literally from the ground up. Every letter and number was completely created by me from scratch. There's no clones. We didn't take Ethereum and change some things. There's no forks. We didn't take Bitcoin and add some things. This is 100% complete, brand new, coded from scratch. And because of that, I can implement essentially space age technologies compared to what those blockchains have with their 10 and 20-year-old tech. And the other thing is that the way that I've built the EbbiCoin blockchain and our backend data layer, I can continue to iterate and upgrade all the features and functionality that EbbiCoin has, not only now, but in the foreseeable future. Whereas every other blockchain that's out right now cannot change. The way that they've created their code, they cannot have updates. Now, you might say, well, Ethereum's updated sometimes, and another cryptocurrency or token kind of changed a little bit. But with the way those things work, with, for example, Ethereum, any minor change, even if it seems like it's for the better, you have to have different people agree on it, and they're always disagreeing on even the littlest parts. And then what happens? There's a fork, and then you get something like Bitcoin and Bitcoin Cash, or Ethereum and original Ethereum. You get all these branches and forks of people disagreeing, and you can never make big progress. Unlike what I've built, as I said, I am making the newest, fastest space age technologies as they become available. And I'm on the cutting edge of these technologies, and I'm coding them myself. And I'm actually on the forefront of creating these technologies. So I'm going to be actually the one pushing these new space age technologies into other markets and industries. So when you see these things later in other markets and industries, it's because they're coming from me. I'm the spearhead of all of this new tech. Other blockchains and cryptocurrencies are literally just a ledger, which means it's like a Word document or a Notepad document or a simple database that says person A has 1 token and person B has 0. That's it. And then on the second block, it says, let's say there was a trade. Now person 1 has 0 tokens and person 2 has 1. That's it. That's the extent of the blockchains, like Bitcoin, Ethereum, all of these other quote unquote big blockchains that are worth trillions of dollars. That's all they do. They're extremely simple. There's no innovative tech. They don't do anything. They're just very simple ledgers, which again, you could do the exact same thing in a simple database, a Word document, an Excel spreadsheet, etc. Extremely basic, rudimentary technology that's 20 years old. Okay, so now that you know about others, let's talk about EbbiCoin, what it is, how it's created, and why it is space age. Now, like I said, I've actually created a brand new technology, which is going to be our backend data layer. And that's how I can do EbbiCoin, is on this backend data layer that I'm going to integrate into all these other large companies and corporations. The technology is very advanced, but I'm going to try and break it down a little bit. Basically, what happens is we have an application layer and a data architecture layer. We have 2 layers combined into one, meaning that we can run applications and have our data connected in one spot. What I've done is virtualize the data and then created a simulated world and put the virtualized data into the simulated world. If you know what a diorama is, and you could imagine a person inside that diorama is in a single room and can only see from a first-person perspective what's in the room that they're in. And let's say you, as a third-person observer, is looking into that diorama. And because of that, you can see the entire diorama, which may have multiple rooms, multiple buildings, a whole city, etc. And you, as a third-person observer, can see the whole thing, all the terrain, every room, every house, all at the same time, whereas one person inside the diorama can only see one room at a time. Now what I've done is I've created that simulated world. I've created a new universe. I virtualized the data in that new universe, in that simulated world. And because of that, we can see all of the data that's in that new universe or simulated world at the same time, Whereas other systems that are currently available, like a simple database system or something that every website and server use right now to see data, it has to go somewhere and ask for the data. It has to send a request to another server, another application, it has to go to a database. It has to go one by one through every row in that database until it finds what it needs, try to pull that data back to a server. That server has to put that data back to a front end. That front end has to show it on a website, and that's how you get data. With my data architecture, the data just exists. So no service has to ask other servers, no application has to ask the database. The database doesn't have to go through multiple layers and check every single record for what it's trying to find. Every piece of our data architecture just has the data automatically. So it's kind of like a teeter-totter, where if one side is up, the other side is automatically down. So let me give you a simple example of this. Let's say a website, any website at all, let's say it has a number of tokens. When you go to that website, it might say your username and it has a number of tokens. That number of tokens is actually a variable that's blank when the page loads. And when the page loads, the server has to ask the database, what is this number that I should put in here as this variable? What is the actual amount of tokens this person has? And again, the front end has to usually ask the back end, then back end has to go to an application layer, then the server has to go to a database, then the database has to look through all its records, it's got to send it back to the server, it's got to put it back to the website. But basically, it fills in that empty space where that variable is with how many tokens that user has. Now, that has to happen every single time we want to check that user's number of tokens. And so you have to refresh the page and do that whole round trip every single time through all of the systems. Also, no company can do what we're doing with data persistence, where what the user would see as their number of tokens is the actual number of tokens automatically, directly from our data architecture. So imagine instead there was a little window, a tunnel, directly to the number in the database. So when you loaded that website, instead of doing all these calls from the website to the server to the database, looking through all the records, coming back and going through this whole thing over and over again, when the user looked at the web page, it was a window directly to the number that was in the database. So the number that they're looking at is the exact number in the database. It just exists. And anytime that number in the database changed, it would automatically change the number on the website because it's literally looking at that number directly. There's no in between or middleman. So this is what data persistence is. This is what I've created. It's actually, we can see all the data at once instantly. So how could this help companies, or how could this help governments? How could this help the banking sector? Well, I just saw the other day that there's a company called Waymo that has self-driving cars. Two of their automated driving cars crashed into each other. So if they were using my system, this application layer and data architecture that I've created, what would happen is that each car would actually be a copy of the same server, and both of those cars would actually link together. Okay, we actually have a mesh network built into our application layer, so we can actually have them, what we call nodes, communicate with each other without even needing the internet. They just talk directly to each other. They can use the internet, but they don't have to. So each of those cars, which were self-driving, would have a node on them, and this keeps the entire quote-unquote database. We don't use a database, we use our data architecture, but I just wanted to make you understand. It keeps a complete copy of the data architecture and application layer on both cars. And so when those cars are driving and picking up telemetry data, speed, it could be wind speed, it could be road conditions, where they're located, GPS coordinates, anything, those are constantly updated instantly, as opposed to what they are now, where a car drives 1 foot forward and it has to save it in a computer that's on the car, then it has to send that somewhere through the internet, then it has to hit a server that says, hey, what car is this? Then that server has to go through some kind of security layer. That security layer has to go to a database and say, save this new record in the database. Then it has to go back, and back to the car, and then tell the car, okay, hey, I saved this in the database. So it's a big problem going back and forth. And what happens? The car says, hey, is there any cars around? It goes through the whole system, and by the time it comes back, it's already crashed into another car. And that's what's happening right now today. Whereas, like I said, with our data architecture, none of that would happen. All the data that it's saving from telemetry is saved instantly, and it's persistent. And that persistent data is connecting to the other second car, which has the same persistent data. So while car number one's telemetry is updating, it's automatically cloning and copying it to car number two instantly. They don't have to ask questions back and forth. Hey, can you tell me your telemetry data? Are you too close to me? Hey, no, I'm not that close to you, right? They have to talk back and forth. That doesn't happen. With what I've built, the data is instant. So they both just automatically know where the other one is all the time. So they can never crash into each other. So this would be a big solution for Waymo to keep their cars from crashing. Because number one, like I said, they don't need an internet connection. We have built-in mesh network, so those two cars would directly talk to each other, no third-party server involved. So it would save a ton of space, for example, in a data center where they need loads of servers for all their cars. It would save tons of data going back and forth between the cars and the servers located somewhere else. The cars directly talk to each other. They'd also be like two pieces of one server, so that's good. But the next thing that this means is that every time they want to add something new to their data, it would also be instant and final. So this means that Waymo could start to add loads of data to what their cars are actually bringing in their telemetry. So then they could start to add weather reports. They could start to add, is the road slick or not? Is there something in the road? What speed are other cars going to? See if another car is on the expressway and it's going 10 miles an hour in a 70 mile an hour, then they could know that there's traffic on the expressway, and all the other cars, could be 10 cars, could be 1,000 cars, as soon as the one car on the expressway is going 10 miles an hour in a 70, every single other car would immediately know there's traffic on that road and to reroute any driving around that instantly. This is a big deal because Waymo could then start to implement every single thing that I mentioned and anything else they could think of, and all of that data coming in would instantly go out to every other car at the exact same time and be persistent. And this is the type of thing that can be put into a bunch of different companies that actually do logistics for cars driving. Could be Uber or Lyft, could be Waymo, other self-driving car companies, could be Teslas, could be a trucking company, could be DHL, could be UPS, any company that tracks trucks or has traffic driving around. Obviously, they could implement this into all their systems, and they know where all of their trucks are immediately. There's instant finality. One truck could tell another truck, don't come this way because there's traffic or there's been a crash. There's just so many possibilities just for this one use case alone. And another use case that's amazing is for robots. Right now, there are plenty of companies, and Elon Musk is one of those people. I think it's coming out of Tesla, where they're actually making humanoid robots. So something else that's amazing about what I've built is that each node keeps all the data from all the other nodes. So for example, if you had 1,000 robots that all had their data spread out, all the telemetry data, user data, whatever data that they're saving, they could all, again, know where each other are. If any of them have an issue, they could all know about it immediately. But what this also means, if there was some sort of attack or EMP or some problem with the robots and all of them got destroyed and only one of them survived, whenever you turned the other robots back on, or whenever you made new robots, the first robot would automatically repopulate all of the other robots again with the application layer and the data architecture. So that means that there's persistence, and anytime a new robot came online, all the other robots would automatically seed that robot with all of the data architecture and application layer data, and it would just come online, basically learn from all the other ones, and then be ready to go. And again, if all of them went down or one got reset, as soon as it came back on, it would connect to the other ones through mesh network or through the internet. And if there's no internet, that's fine. They connect to each other. But then it could just repopulate all of the data and then continue to work as normal. So this is huge. If you have robots just generally on Earth helping people, if you have robots in space, if Elon is sending robots to Mars or the moon, you could have an antenna that uses radio signals instead of what we're using right now, which is low energy Bluetooth, BLE, for here on Earth, or through internet connections. But you could actually blast this signal from all of these nodes through radio waves, and that way, anytime a robot went down, it could just basically get all of its information back again from anywhere. So this is really big, obviously for things on Earth, obviously for robots, for automated cars, and I could go on and on. There's so many uses for this in banking systems. Obviously, if you have 1,000 branches in a bank, and when one bank updated the balance, instead of having to, again, go to servers and go to backends and go to a warehouse and then update multiple servers and update multiple databases and do all this stuff. Instead, if you had 1,000 branches and when one branch updated a user's balance, the amount of money they have in their bank account, it automatically fed that to every other branch instantly so that all of them were updated instantly. There's no opportunity for data loss or hacking or a problem with the servers. And then also, all of those branches are connected through the mesh network in the application layer. So even if there's no intranet, those banks could continue to run transactions normally, and they could all still talk to each other and, eventually their central bank. And that's the next thing is we'll be working on going into central banks and replacing the SWIFT system and a lot of other really cool, amazing things. But this technology that I've built, this virtualized data in a simulated world, plus the mesh network, plus the instant finality, plus the data persistence, just everything that I built, as well as it being quantum secure, kind of need to mention because if you're a bank, you don't want your systems to be hacked by quantum computers. I mean, the same thing if you're running basically an army of robots or even self-driving cars, you want that to be secure. You want them to be able to be hacked in any way so that someone takes control of your self-driving car or hacks your bank account. So the quantum encryption that we built into this really makes it a big advantage for everybody. So this is what I'm working on the back end that we're going to be integrating into every company, every government, every bank that we can. It's just amazing tech. And as I said, every time we bring on a new company, they'll have their own side chain on the EbbiCoin blockchain so that their transactions are private. But we're going to make them pay a percentage of EbbiCoin to use those side chains, as well as they'll pay us a licensing fee. So that means if you're holding EbbiCoin, like any of the front end users on this site, if you're holding EbbiCoin, obviously the value is just going to skyrocket because it's actually being used by these big companies and businesses. And we're going to start integrating our blockchain technology into all these different markets and industries. So now that you know a little bit about the back end and the data architecture that I built that allows me to create EbbiCoin on the front end, let's talk about how the EbbiCoin blockchain works for you guys on the front end. We have some extremely innovative technologies that we've implemented that really just makes this so different from other cryptocurrencies and blockchains and leaps and bounds ahead of them. The first thing is that we have a dual layer consensus layer, which has never been done before. Some blockchains have proof of work and some blockchains have proof of stake, but we actually have both of them. We have it for extra security as well as the ability for more people to participate in the actual blockchain. So this makes it even more decentralized and allows people to earn from the EbbiCoin blockchain in a more easy manner. So with proof of work, the first thing that we've done is that we've made it ASIC disadvantaged. So you don't need to buy these big, beefy ASIC miners that have been happening with Bitcoin, that they cost $10,000 each, and you have some big warehouse in China get all of the mining rewards. We wanted to make sure that that doesn't happen. So that is actually discouraged, and in our actual code, I've made it so that if you're using something like that, you actually get less rewards. So it's not a reward for who has the most amazing supercomputer that money can buy. It's actually properly distributed and you can run it on anything. And I mean anything. I built this to run on IoT devices, so any Nest thermostat in your house, so any smart thermostat, any Ring camera, any cell phone, any old laptop, any computer. I built it to run on anything so that anybody can participate as a miner. So basically what happens is you just run our cell phone app or app on any of the devices I mentioned, and it just helps to process transactions on the blockchain. And as a reward for helping to process those transactions, you get EbbiCoin. So that's the first layer of consensus. That's the first layer of security for the blockchain. Then, once we have the block mined, we send it down to the staking layer, where anybody who has over 10,000 EbbiCoin staked in their wallet can help to process and confirm the transactions on that second layer. That way, people who have been around for a long time and people who have a big stake in EbbiCoin can participate in that secondary layer, and they can earn rewards as well. So even if you don't have the ability to purchase a large amount of EbbiCoin now, so you can participate in the staking, you can start off as a miner. And as you build your EbbiCoin balance from rewards from mining, then you can stake that balance, and then you can start earning rewards from a miner and as a staker. So you can earn double the rewards, or you can stop mining and just stake. It's really up to you. But I built this so that it's twice as secure and that more people get rewards, because that's what we really want with all of this, is for it to be extremely fair for everybody, that anybody can make money from this, that everybody can earn rewards, and that it's completely decentralized. Those are the most important parts of this. This also extremely reduces the amount of electricity and resources that are needed in order to mine. Right now, for example, Bitcoin miners are taking up so much electricity and so much cooling power. It's even more electricity to cool all their miners. All of that is just going to waste. And right now, the world does not need another blockchain that's just stealing energy for basically nothing. Just to update a simple ledger like I talked about earlier, it just doesn't make sense. It's not sustainable, and that's what I've solved. So you don't need loads of electricity. You can run the app right on your cell phone and not even notice it because it barely uses any electricity. You can use an old laptop, IoT devices, literally anything. The third way that you can get rewarded by participating in EbbiCoin is through our mesh network. So EbbiCoin uses the same mesh network that I talked about that we're implementing for these large corporations into the EbbiCoin blockchain. So what this means is that you can actually do transactions when you're not connected to the internet. So what happens is, while you're connected to the internet, you transfer EbbiCoin to your offline wallet, and then you're allowed to use that offline wallet even with no internet connection. So this means that if you were on an airplane and had no internet signal, you could buy refreshments with your EbbiCoin, or you could trade with another person on the plane. If you were somewhere where you didn't have internet, it was somewhere rural, you could still trade EbbiCoin with other people back and forth. And if you maybe flew to another country and you didn't have a SIM card yet, or you didn't have internet on your phone, you could still trade your EbbiCoin with other people. And how this works is, if both people don't have an internet connection, it will still do the transactions. I coded it so it can't be double spent, it can't be hacked, nothing can be edited. It's 100% secure. Those people would do the transactions, and at which point either one of those people reconnect to the internet. It would post all of the transactions from both people. It would pool them and post them to the blockchain that's live, and then it would re-update the person who had connected to the internet with all the new blockchain data. So the person that never connects to the internet, they never have to. They can keep doing transactions with their offline wallet indefinitely. And when that second person come back to the first person again, it would actually re-download the new blockchain information to the person who never connected to the internet. So you could basically have a large population who trade amongst themselves and never actually have to connect to the internet. You could just have one person travel in that was connected to the internet before, and then connect to one of their phones. And when that happens, that phone would use the mesh network to re-update all the other blockchain data for the entire city. But the next thing is, if two people are doing a transaction and one person doesn't have the internet and the other person does, then the person who has internet, it will have it posted to the live blockchain. But if both people don't have the internet, what we have it doing is that anybody else that has our app downloaded, it will check to see if anybody else has internet within 300 yards using low energy Bluetooth, or BLE. So our system can automatically check to see, is there another node around it that does have internet? For example, a person standing 300 yards away with a cell phone on that has our app running. And if it checks and that person does have the internet, it will encrypt and encapsulate that data, send it to that other node, pool it to the blockchain, and then come back and tell the first two people, hey, just so you know, your transaction went through our mesh network and it went live to the blockchain, even though you both don't have internet. And that person, that third person who processed the transaction, they'll get a reward as a part of our mesh network. So that's the third reward, is if you help to process a transaction that's not yours through your node on the mesh network. That's a third reward. So staking, mining, and a part of the mesh network, that's how you earn rewards. And something that's really cool about this mesh network that I built so far is that it can hop up to 5 people. So think about this. You have 2 people that are doing a transaction with no internet. There's one person 300 yards away. And so our system checks that guy and says, does that guy have internet? That he doesn't. So then it goes from that guy to a second guy, another 300 yards away. Checks if that guy has it. Nope. Then it jumps to a third guy and a fourth guy and a fifth guy, all 300 yards away from each other. If that fifth guy has the internet, our system will send those transactions through all 5 people. And when it gets to the 5th person, again, we encrypt and encapsulate everything so nobody can actually see the data. Nobody can hack it or change it or anything. But that 5th guy, he'll pool all those transactions together, post it to the blockchain using his internet connection, and then that signal will bounce back through all 5 people, back to the first 2 people who don't have internet, and tell them, hey, just so you know, your transaction went live on the blockchain through the mesh network. And each one of those 5 people that it bounced through, all of them will earn a portion of the rewards. So even if you don't have the internet, but you're a part of those 5 hops to get to somebody who does have the internet to post the transaction on the blockchain, you'll still earn rewards. So we've made a ton of ways to earn rewards, whether you have internet or not, whether you can mine or not, whether you can stake or not, whether you're just a part of the mesh network. We made it so simple to earn rewards and earn EbbiCoin so that you could literally make money just from having the EbbiCoin app turned on your phone. And anytime a transaction happens around you, if it bounces through you as part of the mesh network, you'll get a notification on your phone that just says, congratulations, you just earned EbbiCoin because we processed a transaction and you were a part of that mesh network transaction. And as I mentioned, you can add it to any IoT device. Anything that has a processor and a little bit of memory can be a part of this mesh network. The next thing is speed and the amount of transactions that we can actually process, which other blockchains call TPS, or transactions per second. Other blockchains are set, as I said, in their ways. They cannot change, they cannot update, they can't do anything. For example, Ethereum has a very specific block time and a very specific block height. And what that means is that there's a certain amount of transactions that can go in a single block on the blockchain. When that data is filled up, everybody has to wait. And they have to wait the block time. Let's say 5 minutes. They have to wait 5 minutes for that block to be confirmed and a new block to start. And the next 1,000 transactions, which is block height, could go into that block. So let's say there's 10,000 transactions waiting. The first block could only do 1,000. Wait 5 minutes, then the second block would open up, 1,000 transactions would go there, and everybody else would have to wait again. So this makes it so that if there's some huge influx of transactions that happen, everybody has to wait. There's nothing you can do. There's only so many transactions that can go in a block, which is block height, and there's only so many blocks that happen in the block time, which is usually 3 minutes, 5 minutes, etc. So that's an extreme amount of time to wait. This is why there were so many issues with Ethereum before, having huge gas fees and everybody having to wait, transactions taking hours. Bitcoin is like that now. The transactions per second are minuscule, like 7 or 8 transactions per second. And there's nothing those blockchains can do to fix this. That's just how they're coded, and that's how it works. There's nothing else they can do. So with EbbiCoin, as just like with everything else, I did the complete opposite. And I came up with a super innovative way to make this scale infinitely. So what we have is a hybrid block controller. And so what happens is once every 10 minutes, we do a block, no matter what. And that's what's called a heartbeat block. That block is actually used to make sure that we're still getting data from all of our nodes, and it also helps to update every node with the newest settings. So for example, if something happened and all the nodes needed updating, then once every 10 minutes, every node would pull in that heartbeat block, which would have all the update data, and it would keep every server and node up to date with everything that's new. But what we do with the actual data blocks is that if there's no data in those blocks, we don't make blocks. So we're not clogging up the network with empty blocks if there's no data. Whereas with the other blockchains, they make those blocks no matter what, whether they're full of data or not. And it clogs up the network and it's giving away rewards for mining blocks that are empty, which makes no sense. But what happens is our system can see how many transactions are waiting, and then it makes the right amount of blocks to process all those transactions. So if there's 10,000 transactions waiting, and let's say we have a block height of 1,000, our system would say there's 10,000 transactions waiting all of a sudden. We can only put 1,000 transactions per block. Hurry up and make 10 blocks. And what my system would do is it would make those 10 blocks instantly, put 1,000 transactions in each block, and then push all those blocks to our consensus layer so that the miners could all start processing those. So every node would start processing those blocks. All 10 blocks would be processed immediately because we have this special data layer I talked about. It has instant finality. So as soon as it's mined from the miners and confirmed by the stakers, that's it. There's no number of confirmations like you see with other blockchains, where even once it's posted, it has to be confirmed by 2, 3, 4, 5 people and then wait for 10, 12 confirmation. None of that. We have instant finality because of the innovative data layer that we've built. So once it's mined by the miners, which is very quickly, and then confirmed by the stakers, which is also very quickly, then the finality is instant and it gets blasted out to every node instantly. And this means that we're not bogged down by a hard-coded block height or a hard-coded number of blocks per minute, like literally every other blockchain. They're not innovative. They don't think of new ways to do things like I do. So they just keep copying the same old worn out technology that honestly sucks. And I'm making brand new tech that actually makes sense. So if we have 1 million transactions waiting, if we only have 1,000 transactions per block, my system would see that, create the right amount of blocks, and start pushing them out to our consensus layer, to the miners. So there's an infinite amount of scaling that happens on the block height and block size, which doesn't happen anywhere else. There is a literal finite limit to every other blockchain because they only have a certain amount of blocks and only a certain amount of transactions in each block. That can never change, that can never get better, it can never be upgraded. That's what it is. And those systems are built 15 years ago. So this old code, old ideas, it cannot be integrated to mainstream. Bitcoin cannot. Ethereum cannot. XRP cannot. Nothing can do what I've built. EbbiCoin can. So the next thing is this transactions per second, because this is really important because, as I said, any other blockchain cannot replace the banking system. It cannot go into central banks. It cannot replace Visa and MasterCard. It could not replace the SWIFT system. They cannot do enough transactions per second. It's just literally impossible for all the reasons I just mentioned. Where EbbiCoin can. It can do all those things. Not only can it do those things, but it can keep all the data persistently and through a mesh network, so it doesn't even need internet. Okay, so let's make some comparisons with other blockchains. Bitcoin, which people have been pouring money into recently, it's just a very simple ledger, has no application layer, has no data architecture technology, it's not quantum encrypted, it's not protected from super cute computer clusters, it doesn't have a mesh network, it doesn't have peer-to-peer transactions, it doesn't have instant finality, it doesn't have a dual consensus layer, it has nothing cool or innovative. Just a simple ledger, says this guy has one thing and another guy has two things. Bitcoin, transactions per second, 7. Ethereum, 15 transactions per second. XRP has 1,500 transactions per second. But I need to clarify, XRP is not a decentralized blockchain like Bitcoin or Ethereum or EbbiCoin. Okay, XRP pre-mined a bunch of fake tokens and they made a blockchain on their own servers. So they just have a bunch of computers in their office, and the blockchain is not decentralized. It's not really a blockchain at all. It's just a database in their server warehouse. That's it. Their servers just talk to each other. There is zero decentralization. So I want people to understand that. There's been a lot of talk about XRP doing this and doing that. XRP is not a decentralized blockchain. Please understand that. Also, unlike every other blockchain, there's no mining rewards, there's no staking rewards that happen as blocks are created. Okay, that's very important. They automatically made billions of tokens. just instantly. And those exist automatically. They're not earned over time, nothing. Okay, so let me just put that out there. XRP is completely centralized. It's only run on their servers. There's no mining or staking. There's no rewards. They just mine them all in the beginning, and then that's it. So they do have 1,500 transactions per second, but it should be way more than that because they're just running a database inside their own servers. It's not decentralized. It's not like us going out to nodes all over the world through mesh networks and doing all, it's just basically a database in their servers. Anyways, so their transactions per second is 1,500. So Bitcoin is 7, Ethereum is 15, XRP is 1,500. Currently, with our configuration, EbbiCoin is at 10,000 transactions per second. 10,000. And that's with zero mesh network. And this is where we start to get into really cool tech because unlike every other blockchain, whatever they are right now is what they are. We're starting at 10,000, but we have no mesh network yet because we just got started. But what happens is every person who downloads the EbbiCoin app on their phone or puts the app on their computer or puts the app on their Ring camera or their smart thermostat, every single person who does that becomes a node, and every additional node scales up our transactions per second. And so this is also very important because we're starting at 10,000 transactions per second right now today. Bitcoin is 7, Ethereum is 15, XRP is 1,500. We're at 10,000. 10,000 transactions per second. And like I said, because of my dynamic block technology, we can create as many blocks instantly as we need to process even more than that, millions of transactions per second. And every time a new node comes on, the transactions per second go up. So hitting 100,000 transactions per second is very easy to do. With an extra 1,000 nodes on our mesh network, we're automatically at 100,000 transactions per second. And like I said, every single device that we bring on for the foreseeable future adds to those transactions per second. And because the block time is dynamic, there's no scaling issue for our block time. It can be millions and millions of transactions per second. So the only thing that's restricting us to 10,000 right now is the number of people who are participating in our mesh network. And since we're just starting, we don't have any yet. But once we start to hit 100, then that 10,000 transaction per second goes to 15,000. That transactions per second goes to 30,000. Then 50, then 100, then a million, then 10 million. This is built to scale. It constantly gets better. It constantly evolves. It has instant finality. It has data persistence. We have mesh networks. We have person-to-person transactions. So two people can just tap their phones together and trade EbbiCoin automatically. All of it is quantum encrypted, so it can never be hacked. Nobody can see your transactions, even when it's going through the mesh network in order to get pooled and post from someone else. All of it is completely secure, completely amazing, and it always just keeps getting better. Unlike all these other blockchains, what they are is what they are, and they will literally never get better. They're just not coded that way. They cannot get better. And the last thing I want to talk about is our quantum proof security. Because this is a big issue, and every other blockchain shortly is going to start being able to be hacked. Elon Musk just made a post on X the other day where he asked Grok how long before quantum computers can hack blockchains, which was amazing because I've been working on this tech for the last 6 months straight, and Elon Musk just randomly posted that the other day, which lines up directly with what I've been making this whole time because I've seen the writing on the wall for a while. And so let's talk just a little bit about this quantum proof security that we have. I've actually built quantum security into the literal blockchain. So right now, with other blockchains, when you go from one block to the next, takes all the data from the first one, encrypts it using SHA-256, and then puts it into the second one. So the actual blockchain uses what's called SHA-256 for encryption, but that's going to be easily broken by quantum computers in 5 years or less. So I've actually coded the blockchain to use something called Blake 3 instead of SHA-256, which makes it quantum secure. So quantum computers cannot hack it. I don't want to get into the deep intricacies of how these systems work because it's a whole nother thing. It could be an hour-long video on those things. And maybe in the future, I'll make a video just about our quantum encryption because honestly, it's amazing. But so our actual blockchain is quantum encrypted, the actual chain. The next thing is that other blockchains, they're going to be vulnerable to historical attacks, meaning that since each block is based on the previous one, a quantum computer or a supercomputer node or cluster could actually go back in time and change a block 10 years ago, change the data so that they could then come to the newest block and change the data. So when the new block goes back 10 years ago to an old block, it'll say this data matches from 10 years ago, this 10-year-old block. It's been here the whole time. So somebody could change people's balances, could do all kinds of things in this historical attack. I've done something special. So separately from using Blake 3, we have a separate protection that's called Sphinx Plus, and we use checkpoints. So what happens is that every time a block is confirmed, we actually, obviously it's secured by Blake 3, like I said, instead of SHA-256, but we use Sphinx Plus to lock that block down so that no quantum computer could ever hack it. So this is super important. Think about if a quantum computer went back in time and changed a balance for somebody today to 1 million, and then that person just refreshed their screen and now it says they have 1 million Bitcoin or Ethereum because they went back in time years, changed a block to say that they had 1 million coins then, now come to today and it shows 1 million coins. That's a big problem where people can just edit any old transactions they want, which would change the transactions today. We use checkpoints. Every single block that gets confirmed after it goes through our mining and our staking consensus, which is extensive already. Then it gets instant finality posted to the blockchain. And then we use Sphinx Plus as a checkpoint. So we lock that down and it can never be changed ever. Nobody could ever go back in the past and change them forever. That's huge. I mean, that alone is amazing. Also, we have memory security so that all of the things that are loaded into memory for our P2P transactions, all of our quantum encryption for offline transactions, it's all in secured memory. So we lock down the memory. So even if a hacker tried to go out of their way to read the memory somehow and like hack packets, you can't. We have Kyber signatures for the P2P transactions, which again, I won't get deep in, but just know it's amazing. We use Kyber signatures for that. We use dilithium 5 for post-quantum signatures. We use it in all the transactions. We use it for nodes to connect to each other. So basically, let me just run you down real quick. If you're a security expert and you know what I'm talking about, you're going to be amazed. If you're not, don't worry. Just understand this is amazing because no other blockchain has even one of these things. Okay, we have dilithium 5 for our post-quantum signatures, transaction security, and all of our transactions that happen and connections from node to node. We have Blake 3 for our blockchain and mining. So instead of using SHA-256, we use Blake 3 in the actual literal blockchain. We use Kyber signatures for quantum secure connections to the mesh network and for P2P transactions. We use Sphinx Plus for checkpoints, like I said, to protect against quantum historical audits. We have memory security, where we have enterprise-grade secure memory management. Like I said, someone can't read the memory, which would be super hard to do, but if you were a government, you could try. That's completely blocked out. So we have 100% full stack protection against all quantum threats. All quantum threats. So we have this built into our wallets. So think about if you make a wallet somewhere else, you can easily hack that with a quantum computer. We use special mnemonic phrases and we connect it directly to our quantum encryption. So even quantum computers can't even break our mnemonic phrases or passcodes for our wallets, for transfers, anything. And so, I actually wanted to kind of get a more bombastic idea of how I could say this to you guys. And so I went to our good old friend ChatGPT to ask a question for marketing purposes. Shout out to Sam Altman. But I asked it, can you describe how secure my dilithium 5, just dilithium 5. So I named 6 things that we use for our quantum proof security. I said, just for our dilithium 5, okay, just for our transaction securities only, how easy would it be for a quantum computer to hack this? And it said, in no reasonable amount of time. And so I told it, okay, ChatGPT, be more bombastic. Tell me exactly, because I want other people to understand how amazing my tech is. And so ChatGPT told me, this is a quote from ChatGPT. Even if you had a quantum computer the size of a football field with millions of qubits running at full speed, it would still take longer than the lifespan of the universe, which is trillions of years, to break a single one of your dilithium 5 signatures. So your assets stay secure no matter what the future holds. Wow. That's mind-blowing, right? And again, that's only dilithium 5 that it was talking about. That would take trillions of years to break. And we've got dilithium 5, Blake 3, Kyber signatures, Sphinx plus memory security, and everything else you could imagine. The tech I've built is literally military grade, it's government grade, it's space age. You cannot get more secure. The technology literally does not exist. I have the best technology that exists for quantum proof security, but I think it's really important. Obviously, there's a ton of amazing things that are happening with the front end, with the EbbiCoin, and on the back end with our data architecture for companies that we can integrate to banks and self-driving car companies and robot companies and Teslas. But this quantum security for everybody has to happen. This has to happen. Even if somebody wasn't interested in anything else and they just wanted their company data to be quantum secure, they have to do this. They have to. Even if you are thinking about buying a coin from another blockchain, you're going to get hacked. That blockchain will be hacked. And there's nothing you can do about it because those blockchains cannot be updated. And EbbiCoin is the place to secure your data, your coins, your company transactions. Literally everything needs this. This has to happen. So me having built this already is, I think, the most important part of everything that I've talked about so far. And this leaves one important thing to talk about at the end here. I'm building bridges to every other blockchain. What this means is that you can actually transfer your Bitcoin to the EbbiCoin blockchain and have it be quantum encrypted and quantum secured. Because again, all of those other networks, all of those other blockchains, they're completely insecure. But what that does is it means that every user could transfer all of your Bitcoin into our EbbiCoin bridge, and it would stay as Bitcoin, but it would be on our quantum encrypted, quantum secured blockchain and data network with the application layer and the data architecture. So think about a person transfers all of their Bitcoin to the EbbiCoin blockchain through our bridge, and then they want to spend some Bitcoin for some reason or give it to somebody else. They could just transfer the exact amount of Bitcoin they're looking to spend off of the EbbiCoin bridge and back into Bitcoin. Then they could send it or sell it or do whatever they wanted. And that way, when quantum computers do start hacking the Bitcoin blockchain, their Bitcoin wouldn't be there to be hacked. It's already locked in to our EbbiCoin bridge and it's already quantum encrypted. So this makes EbbiCoin as a blockchain and as a system, the place to hold your coins and tokens, regardless of if it's EbbiCoin or not. If you want to hold your Bitcoin, if you want to hold your Ethereum, if you want to hold any token on Ethereum you can think of, you can transfer it to the EbbiCoin blockchain using one of our bridges. And at least then you know that it's 100% secure and quantum encrypted with dilithium 5, Blake 3, Kyber signatures, Sphinx plus, memory security, all of the things that I just mentioned. So I think this is a really cool use case. And I think we're going to start working with other large holders of things like Bitcoin ETFs, investment firms, in order to have them transfer all of their assets that they're currently holding, no matter what token they are, into our network. So at least they're safe, at least they're quantum secured, and at least that way you know that if you're an investor in those companies, your Bitcoin is not going to be easily hacked by any quantum computer in 5 years or less. So that's everything that I wanted to say right now about EbbiCoin, about the EbbiCoin blockchain, about our data architecture and our application layer. All of this, honestly, it's extremely innovative. I built it from the ground up. And it's amazing technology. Nothing else compares. It's a completely new way to do blockchains, process transactions, integrate with brick and mortar companies and services and governments and banks. It has a mesh network, no internet needed, peer-to-peer transactions, dual layer consensus, auto-scaling block height and block time, quantum proof security, and the list just goes on. And I'm going to continue to keep making new products and services and then putting them on the EbbiCoin blockchain as well. So this is really just the beginning. I'm so happy that you're here at the beginning so that you can actually participate in the huge and massive growth and adoption of EbbiCoin. And like I said, our data architecture on the back end. People now, if you ask them if they could go back in time, what would they do? You probably get 80% of those people saying they would go back and buy Bitcoin when it was early. And like I said, Bitcoin has no technology. It does nothing. It's just a simple ledger. Can be hacked by quantum computers, and it can't integrate into anything. So think about that when you're looking at EbbiCoin, everything that I've built, all the new tech, all the amazing innovations, how it can be integrated everywhere. Wouldn't you want to be a part of EbbiCoin at the beginning more than you would have wanted to be a part of Bitcoin when that started? So just think about that. You're on the website now, hopefully ebbicoin.com. Create an account. We're doing a pre-sale right now, a discount sale, so you can get EbbiCoin at huge discounts, but there's a finite and limited amount. So make sure you get in there and get your EbbiCoin now, because once this starts to take off, the supply of EbbiCoin is basically going to go to zero, and you're only going to be able to purchase EbbiCoin from other people or get it as a reward from mining, staking, or being a part of the mesh network. So hurry up and get in, make your account, get as much EbbiCoin as you can, and I can't wait to see you on the inside.